Alright guys, I've started recording. I'll be sharing my screen. I hope that everyone can hear me. And kindly confirm once you start viewing the screen. I'll share my entire screen so that you can, and not just the window, so that you can see everything. Please confirm that you can see the screen before I begin.
I can see it.
Okay. Mm, so that means, okay, so it means it's active. So, like I was saying, in day three we covered most of the work that we did in day two because the network and the audio wasn't good. And if I can just do a quick recap, in day one we did grid lines. In two, day one we did grid lines in the x direction and the y direction, right? In the in the vertical, horizontal. And what we did was that we named them, the ones in the y direction, we named them in letters. That's from A to this is a newer file to N. And then for the ones in the x direction, the horizontal ones, we named them, we gave them numerical numbers, right? But this is not to say this is exactly what you need to do. Sometimes you can interchange. Really, it's according to your preference. And then you can also give them other names and full words. Just make sure that whatever it is that you identify the axis as, it's covered in the small box that comes with Prota. For example, here, as an example, I would have typed the entire word. And if you remember, when you are placing grid lines, you go to the menu here, and I hope that you can see it. You can either choose the orthogonal one. Let me just do a quick example. You select it. So, like AutoCAD, Revit, and other design softwares, you need to pay particular attention to the bottom here, it's called the command line, right? AutoCAD has it, Revit has it. So sometimes it really helps you because it will be telling you what to do. For example, this one gives you the Z direction. That's either the depth or the height. These are the units in millimeters and also the pressure. Is it kilo? It's moment. Kilonewton per meter is moment, right? Pressure is kilonewton per square meter. And then you've got these coordinates according to the cursor. So I've got my cursor here. The more that I move it to the other direction, it goes into the negative. Also here, you can see this is like a quadrant. For those who remember quadrants, right? Some sophisticated whatever. So you've got the positive, the x positive. This is a positive x, negative x, positive y, negative y, and so on and so forth. In 3D, you also have the z. You see, this is the global coordinate system. This one is the local, right? So let me go back to my plan, and then what you do when you open it will be completely blank. So you need to place some grid lines. So when you hover over it, it will actually tell you it says orthogonal axis generator. When you click on it, here on the command it says pick the reference point, lower left of the group axis. So when you press, it gives you this orthogonal axis generator, and then it gives you the grid insertions where you've selected in the x, where you selected in the y. This is not really important. And then insertion angle, what's important is the direction axis in the x and in the y, right? So here it tells you that you have, for example, in this direction in the axis, it will give you alphabetical letters. In the second direction, it will give you numerical letters. And then the spacing, it's telling you it will give you 5,000 meter, 5,000 millimeters, meaning 5 meters. And the extension, meaning the length, from one A to the other is going to be 2 meters, right? And then in this one also the same. So if you're good with this, if you're working in, for example, what you're designing is going to be like more of a box, this works for you. Let me show you. So when you OK it, if you do not change anything, When you okay it, where you had inserted, someone is requesting, just hold on. Okay, Marcus. Okay, so as you can see, because it should have started on 1, 2, 3, 4 if you had opened a new one, but because I'm working in this field where I already have 1, 2, 3, 4, it picks up, right? It picks up from 4, 5, 6. If you did what I did and if it was a blank working area, you should have had 1, 2, 3, 4. So this was the X, the numbers was the X, this one was the Y. Also here you see it doesn't start from A, B, C, D because I've already used A, B, C, D, right? But suppose you were to open a new one. In fact, let me open a new one. Let me just select this, delete, and then I'll save this one. I'll get back to it in a while. But when you open a new one here, whether you double click on your desktop, the Prota software, or if you're already working and you need to create a new one, here you go to file, you say new project. Here open project, it gives you projects that you've worked on previously or that you're currently working on. But a new project is completely a blank template. So let me call this one example, right? Or example one. And remember, when you're naming files in Prota, no spaces. You can only use hyphens, underscores, caps, capital letters, small letters, numbers, and so on and so forth. So this can work. But if I had added, actually I'm pressing the space bar right now, but it's not working. But if I press one, it does. A hyphen, it does. An underscore, it does. You see? So example one, okay. And then remember the templates according to the codes that you're using or the codes that your country uses. If you're in Turkey, you'll be using Turkish codes. In Singapore, Singapore uses Eurocode. Ireland, Eurocode. In Zambia, we use either the British Standard, the BS, or the Eurocode. But for most parts, a lot of people use the British Standard. So you click on it, you import, and you have a new working area. So doing what I did, you go to the orthogonal. Here on the command, it tells you pick a reference point. You select any point, and then you know that your A is the Y direction according to what we just did. And your numbers are the letters are your Y direction. The numbers are your X direction. You can either increase or you can change the spacing, which will make the span, or you can leave it as is. You okay? And then you see now it starts from 1 to 4, and then so it was saying 5,000 by 3, right? So this area is 5,000. This is another 5,000 too. Or this is the first 5,000, second 5,000, third 5,000, and so on and so forth. This is the first, second, third. So suppose, let me delete that. Also to delete, you can either you click from you click and hold from bottom left to from top left to bottom right. You'll be clicking everything that's within. Yeah, so you'll be selecting everything that's within that box that you created like that. But for if you start from here, similar to AutoCAD, if you start from here, you can only select whatever will be covered. For example, here, only these were completely covered. The ones at the top weren't. So when you do that, now everything is covered, right? So I'll delete that, okay? And then let's try to switch it up a little, to spice it up a little. Previously, I click. So for example, I can say, let me shorten my spans. I think 5,000 are too much. I say 3,500, right? This is standard for the most part. And then I would like to have maybe 6, right? I'll do the same. Okay, here I'll switch it up and say 4,000, right? And then 6 also. I okay. And as you can see, it went up to 7, but then the spaces are 6. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. If you pay attention, you can see that these are longer, these are shorter. If you'd like to confirm, right click, use the measure tool from one insertion point to the next. You remember we said what, 3, 5? This is 4, and then from here to here is 3, 5. The shorter ones are 3, 5, the longer ones are 4. So usually if you know where you're going to be working is going to be in such an environment where it would make sense for you to have this system, a square-like system, you can use the orthogonal. But then, for the most part, a lot of people will just be inserting these grid lines individually, like this axis. You start from one point, and you remember if you want to draw them at 90 degrees, the angle is over here. See? Here it says 28, 50 watts. Sometimes it's difficult to get to 90, so you hold down the control button, and then it constrains it in the y direction. And then also it's giving you the length. So that one is about 15,000. The ones that we're getting are like 2. So you do that and you have your number 1. If you'd like a y direction to have letters instead, you right click, so you select, right click, properties, there in the general part you can say A. So much, this is what we did for in lesson in day 1, in session day 1. And then we also placed some columns, and then column placement. But before we place columns, I think we did levels. On the building set out here, you really need to, if you've used Revit or AutoCAD before, then Prota will be so easy for you. However, if you haven't, if you have a drawing, for example, for this challenge, we've been using this drawing. And then in order to know the levels, you probably need to create a section. And our architect here, he created this section. And if you've been watching the session, the basis is that this architect or the client, the owner of this structure, or the employer engaged an architect to design classroom blocks. But then, when the architect made the design, they estimated that the foundation bases and the columns would be 15 by 400. They even went as far as designing the strip footing. A very ambitious architect. Right? But of course this is a guide, right? So they started constructing. This is the hypothetical. I'm giving you a hypothetical situation. So here the floor plan it shows we have 6 classrooms, and if you've had time to study this drawing, you can see that it's almost symmetrical in here, because you've got 1, 2, 3 classes on the left, and you've got 1, 2, 3 classes on the right. And in the middle, you've got a storeroom and senior teacher's office. Also, let me show you another thing. If you've had time to study the drawing, here is 9.3, here is 9.3. This is 1.5, 11.5, this is 11.5. This is 9.3, this is 9.3. So it's almost symmetric. If you were to find the midpoint here, you would have a symmetrical structure. And then also a corridor for access purposes, right? You access the classrooms in the corridor. So then the architect designed this structure as a single story. I hope everyone can hear me and I'm not talking to myself, right? So the architect designed this as a single story, but then construction begins. The client says we would like for it to be a double story. So now they decide to bring, suppose you're a structural engineer, you say, if you've got especially if you've got a structural engineering background, the first thing that will come to your mind is, okay, you're trying to add another floor or another level. Is what you've designed, especially the foundations or the columns and the beams, is what you've designed, is it going to be sufficient to support more loading? Because if this is a classroom block, then you're going to have some dead loads from the concrete itself when it dries, got about 2.8 if I'm not mistaken. And then you have chairs, right? All these things will be stationary. And then when classes are active, you have a lot of dead load or live load from the students, and most of it actually will be dynamic loading because the students will be moving, right? And then when they sit for that particular moment, it will be live up until they exit or when class is over. And then you go back to a situation where you have the dead load, the self-imposed load of the concrete and the chairs and so on and so forth. So here, if I could do a sketch, here if can I? It will take a lot of time. So imagine, I hope you can follow my cursor. Here, you've got, this is a column. And they're saying detail 3, detail 2, detail 10. Detail 3, I'm pretty sure is a ring beam. Let's see. There, 3. Just showing some reinforcement. But then, okay, detail 2 is a strip footing. Let's see. Where is detail 2? Here. Oh, the one at the top. So detail 2 is the figure at the top is basically a load bearing strip footing. Here it says strip foundation 600 by 200. When your foundation is this one here, the 600, 200, right? And then here, our area of interest, detail number 10. This is a foundation base and a column. So it decides to give it a 15 by 15 by 300 depth. So now, if you were to add another level or add another floor on top of this, meaning here you have a slab, right? A concrete slab. And then these columns will have to go further to support the roof truss, right? And then also this will go up, and then what you have here will be at the top. This roof system will be after the first floor. So now you need to carry out a few calculations according to, if you've got a structural engineering background, it's 1.4 G. The G is for dead load plus 1. It's 1.2. Yeah, 1.4 L. Yeah. So 1.2 D, 1.4 L, and then the ultimate whatever. And then what else? You design the section, then you calculate the area of steel, and bear in mind the section, the size of the column will affect the reinforcement that you use. You cannot have a 200 by 200 and use Y16s, right? That's too much. Meaning it's too much steel for that section. Meaning you have to increase the section. You probably need maybe a 300 by 300. You can go back to your books, you can crack and you can check them, and then you'll be able to confirm. So, yeah, where was I? Yeah, so we're on the section here. Yeah, so here this section view, it will give you the levels. For example, the architect estimated the top of the pad would be at minus 100. The strip footing, I guess the TRH is at 1.4. The floor here will be 0 because that's the natural ground floor. The window sill is 1.3 from the ground. The ring beam is that, and so on and so forth. So in Revit, you can easily add these. But then in Prota Structure, you need to go to a thing called the building setup. When you go to it, when you open Prota Structure, it just comes with two levels. This one is the foundation, and then the other one is the ground floor. And they're saying the height of the ground floor is at 3 meters. You can switch between the floor plan and the 3D by right clicking. When you click on the 3D view, there it shows you. So for example, if you, oh, because we haven't added any grid lines. Let me quickly add some grid lines so that you can see. I'll go back, select it with the left mouse button, right click it to go back to floor, to 2D. Select your orthogonal, you OK it. So now if I go back, right click, 3D view, I can be able to see my grid line there, my grid system. And then when I click on 0, it goes down. So that's where my foundation, my topo foundation TLF will be. And then there, that will be the soffit of the, or it will be the top of the ground floor if you wish to add other floors. So this is probably where the bottom of the slab is going to be. Yeah. So if you wish to add more, you go to building setout, you go to insert, and then already we have one. Just count it as one. And then if we add, say, three more, I need three more levels. I'll click on three. I'll OK it. And then it gives you that message. It says this and the previous processes will not be undone after this step. Do you want to continue? Yes, I wish to continue. I OK. And then I have two more. So how Prota reads this is that we said we need three, but then three minus the one that's already existing. So we've added two more. If you would like to have four, let me just delete the information. I'll delete everything to go back to where we were. Remove story. Okay. I'll remove another. Now we are back at where we started, right? Building set out four. Sorry. Insert building insert story four. Right? I click on four, I'll actually have three new ones because four incorporates the existing one here. So this one, two, this one was existing, now I've got one, two, three. And then when I go to building, if I wish to edit, it tells me that all of them are 3 meters. So this is 3 meters, 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12. So that's how you add levels in Prota. And then you add columns. Um, anyway, let's continue because we'll be adding new columns in day 4. So we can jump to whatever it is that we need to learn in day 4. So I don't need to save this. I'll go to file. I'll open the one that we've been working on. It says, do you wish to save? No, I do not. So what we've been working on is, let me just give you a preview of what we wish to accomplish. Here I'm saving it in a different folder. When I OK it, this is what we wish to accomplish according to, yeah, so this is good as a matter of fact. So if I say I would like to go to the left elevation, see how this gives me like a section of the sample, you see? Except we have another floor or another level here, this one. But now what's left is that we would like to have a beam that slants like that, so that we can have that canopy thing, the canopy shape here like that. This one here, right? This one. So if we only needed one floor, this system would have been, it would have ended right here. So this and this would have been here, right? So now because there's a request, that's exactly why we're carrying out this structure analysis. So this is what we wish to accomplish, but this is not what we did. This is so much. Let's open the file from day 3. Open, it's in a different folder. This is the one that we've been working on. And project you want to revert. Yes. Okay. So this is not actually what we did in day 3. What we did in day 3 is I didn't save it, guys. So I'll have to, it brought us back to day 2. So for everyone that didn't attend day 2, this is a bonus for you. And then for everyone that attended and understood day 3, this would be a very good revision point for you. And yesterday, there was all that conversation about, can you guys hear me? You can either type,
Yes, we can hear you. I can hear.
okay, you can chat there, you can send a message, or you can unmute and just confirm that you're following, because I do not want to be talking to myself. Okay, good. It says everyone can hear. Okay. So going back to Prota, yesterday there was that whole conversation about okay, what happens if the protrusion goes, if the steel column goes all the way deep into the, if we hover it, it shows what happens. Well, we talked about those end connections being one of the reasons. Mundia said, unfortunately, he's not in today's session. He said, actually, no, when you design it like this, Proto will actually give you an error message. To an extent, I believe him, but I really just wanted him. I've experienced it before, but I wanted him to be the one to show us, right? It was more of a dare thing. So if you remember, what we agreed on was that. Also, let me show you one cool thing for everyone that's just attending class for the first time. If I right now I've got two windows and they were placed in a vertical, in a horizontal manner, right? But if I were to close one window before I do that, or I cannot undo. Anyway, now I have one window, and here on the left side here on views, basically you can tell Prota the number of views that you wish to have. You can have as I think as many as, I think you can have as many as five. So here you, but I'll do four. So here right now we only have one, and it says it's a 2D view. You can switch. You can go to a 2D. If you wish to add another view, you click on the view, right click, and what kind of view do you want to have? Do you want to have a plan view, another plan view, or do you want to have a 3D view? So I click on 3D. Now I have two. And then I can place them either side by side or top and bottom. Here on this button it says window. When you click on it, what do you wish to do? Do you wish to tile them in a horizontal way like this, or do you wish to have them placed back to back like in a vertical way like this? So I can add another one. Let me add another plan view. Now we have three, right? But then what happens if you ask Proto to tile them now? You've got three. Doesn't look so good. How about vertical? Also good. But four will be good because it's an even number like that. If you place them like so, you got. And then to make each view active, you need, if you need to work in it, you need to activate it. How you activate it is click on it. For example, right now this view is active. If I wish to go to this one, I click in it, and so on and so forth. And then I can close either here to just remain with two or one. For the moment, for the time being, I'll remain with one, right? And then I can double click it to maximize it. So here we've got a situation of where the steel column is getting into the concrete column. This is not how you model or how you design it. It's not the correct way. Why? Because you need to place a connection here, base plate, right? By means of anchorage. In the future, maybe we'll get to learn about that. So this is not a perfect connection. Um, in real life, you're not just going to. There's no way that the steel column will just sit on the concrete column. There's a certain level of connection that has to be there. So for this type of system, the connection method is a base plate and anchorage. So you leave some anchor bolts or you leave some steel bars, and then you come and bolt the plates on top of the of the of the column, the concrete column, and then the steel will be welded on the base plate, and that's how you have the system. The welds come in different sizes. I'm pretty sure Paul will be able to agree with me. Welds come in either 6 millimeters or 3 millimeters or whatever, according to the specification. Yeah. So moving on, we have a situation of where all the columns are entering. The steel columns are going inside the concrete columns. We've agreed that this is not the correct way of modeling, so we need to do something about it. So when you click it and you right click, you go to properties, it tells you here on the 3D, it shows that it goes minus 3,800. So meaning we have to, because when we were modeling, we placed it on top of the eaves, right? It's on the eaves level here. You've got this thing or the wall plate level. When you click on it, the grids, you see, they go right at the top there. So this was our starting point, and then it went down to the ring beam, and then from the ring beam it went minus 3,800. 3,800 that we saw. So now here, when you go to the building setout, you edit. It shows you that this is the workload. I named this. You can describe it. Usually it's just left blank, but for your own good, it's nice if you can name them. So edit story here on workplate. It shows you that it's 118, meaning 1.1, right? That's the height from the ring beam. But in total, the level is that this is just the height of the story. This is the accumulation. For example, if I've got a Revit file here, if I go to south, so of course, for example, from the ground floor here, natural ground floor to the first floor, if I were to measure this, of course, it's about 4 meters, right? There, we have 4. But then from here to here, it's whatever the difference of 4,000 minus 2 is, which is 1/8. So this is exactly what's happening in Prota, right? So in order for me to know the, the, the if I were to subtract 2820 from 4,000, let me pull out my calculator here. I've got 4,000 minus 2820. It will give me the 118, which is here on the left, right? So when I placed it on the wall plate, it went to the ring beam by this measure. But then I want it to sit here. So in order to get here, I would have to subtract the difference of 2820 minus 200. So I'll say 2820 minus 200, it gives me 2620. So I have my 2620. We'll use this one as an experiment. Or yeah, so for the specimen, all right, click properties 3D, and then double click to highlight everything. I'll say minus 2620, 2620, enter, update. Let's see if I have the problem of the intrusion. It's not there, you see. As I hover it, it's ending right there, as opposed to this one, you see, there. So then I can go on and on and on. I can go one by one by one by one changing, but that's extremely tedious, right? So what you can do is you go to the placement level. We were placing them on the wall plate. I'll change to my 2D in order to see them. So you see, I can see them here because this was the placement. I cannot see them on the ring beam because it was not the placement. I cannot see them on the ground. I can only see the placement of the concrete columns, right? I cannot see the steel columns. So my placement level of the steel columns was the wall plate, and therefore I can see them. So you can select all of them to change at once, like this. You can do this, but when you do this, you're selecting everything, including the grid lines, right? But that's not what we wish to do. We wish to only select the steel columns. So you need to filter, right? So here there's this button that says filter selection. When you click it, everything has been selected. So now you can either deselect one by one what you do not wish, or you can use this button here that says select deselect. When you click it, it deselects. When you click it, it selects. So you deselect, then you say, well, I only want to select the columns. You click, and then you go back, perform the selection, and now you can see that it only selects in red. It only selects the steel columns. When you click, right click, you go to the properties, it pulls up this table. It says the column table. It shows you the placement level. Okay, I cannot. it shows you the placement level at story 3 here, right? And then it also shows you the names of the columns because they were being named as you were clicking on them. And then this is the section, the type of steel column that we're using. This is a 265 by 289, and then also the kgs. And then it shows you the DZ top, DZ bottom. That's the delta Z or the height, the start point, and also the bottom point. Here, thank you. Here you can see that some of them are at minus 3,800, and then this particular one is the only one at minus 2,620. And this is the good one. These are the intrusions. So you do not have to go one by one changing. That's extremely tedious and it will take a lot of time. So what you do, you select the top like that, and then you enter the number that you want, minus 2620, and then you press on the enter button and everything changes. You close, you select this button to hide the filter, you select the floor plan, you right click, you go to 3D, and you notice that you do not have that problem anymore, right? The intrusion problem has gone, and now we can, when we go in Prota Studio, we'll be able to model the plate. All right, cool. So we added trusses, right? So also remember placement, extremely important concept. Where do you wish to place the truss? Of course, you do not wish to place it on the ground floor. What use does it have on the ground floor? You definitely do not wish to place it on the ring beam, but you do wish to place it on the wall plate, right? Because it has to rest on the ends or the tops of the steel columns. So you can work in 3D. I personally do not recommend it, or you can work in 2D. I recommend 2D. So you change, you go to plan, you find what you're looking for. What do you wish to do? You wish to place the truss. And what kind of truss is a steel truss, right? You would place maybe a timber truss, but then you would have to think of your connection. How does the timber connect to the steel? Of course, maybe you'd have to use maybe a weld where you thread into the wood and then you create a base plate, and now that base plate will be welded here. But yeah, it's possible, but not the best. Go back to plan. So we're using a steel truss because I can weld steel and steel. I cannot weld steel and steel by the wood. So I go to my steel member. I wish to insert a steel truss, and my insertion level is a wall plate, and I'm in the wall plate level. You see, it's darkened, it's bold here. So you click on the steel truss. Here you see it gives you, it prompts you, gives you a command. Very important. It says pick two axis intersections for member insertion. What that means is you want it to span from here up until here, and then the minute that you select the second point, this truss generator pops up automatically. And then you've got things like, and it also gives a label, it says 3T1. The geometry means what is the truss going to be, what members is the truss going to be made up of, or actually the geometry is the shape. You can have an arched, a rectangular, a trapezoidal. This is like a half trapezoidal, this is a full trapezoidal, and so on and so forth. I'd like to use this one, right? And then you go to members because the truss is essentially just components that have been formed together. So this member, the default member, these are L shapes, so the angles. So that is not what I wish to use. You can, as a matter of fact, because accessibility again, think of what will be on top of the roof. If you only be using the roof for accessibility, for example, if it's got any, if it requires any patching, or if you, it anyway. So If there's nothing heavy that's going to be on the roof, then this can work. Because the only time that you need to go to the rooftop is when you need to service the roof. That's if it's got any leakages and you wish to patch them. So this works. But then if you're designing maybe for a warehouse and then you would like to, like Obi said, maybe it's got some air conditioning units, the outdoor units on top, and maybe a geyser, those solar geysers. So then you have to take that into account. It will have a lot of dead loads that it will need to overcome, and so maybe you need to change the members. So a truss is made up of the top chords. These are the top chords, the bottom, the diagonals, and the verticals or the webs. So you zoom in, you click, you'd like to change the section or the member. In the previous session in day 3, we used the IPs. And the IPs are not from the British code, they're from the Euro. So you change here, you go to the Euro code. And also how you know this, you won't know it like you just start your practice and you have this information. It doesn't come like that. It comes through reading a lot of drawings, watching a lot of tutorials, maybe having sessions with other more experienced engineers. So you will not find the IPE in the BS code. You find it in the Euro, and it's here. And for this station, we'll be using the 200. And then here it gives us all that information that we were looking at. When you select it, you can have even more information here on the properties. The torsion, resistance, the modulus of elasticity, the plastic, section properties. Something that you can review in your own time. You can change the angle, you can, like that. I'll go to default. Okay, I'll put it at 0. That's 90, that's 0, 90, 0. So I want it at 0. And then I'll select. And right there, and then you can see that the section changes, right? And then for the bottom also, bottom code, I'll select the IP also, the 200. In fact, if I wish, here's the 200. If I wanted to, since just by looking at this structure, I know all the top uh, loading will come to the bottom. Therefore, we'll be having either deflection or it is actually deflection. It will be going down, right? It will be compressed if we have an excess. Therefore, the bottom member needs to be larger, bigger to overcome the loading. So I can choose to have the bottom code to be 200. The top code I can even use 140 or 160. In fact, I'll use 120, right? And that's acceptable. For the webs, maybe just the middle one, but I cannot directly go to the middle one. I do not know how it counts. So I don't know if it's 1, 2, 3, if it's the fourth one. Yeah, so you can, something that you can do and try to find out. So I'll maintain these other ones as they are, and I'll say okay. And right there and then, when you still active, it's still in the command. What you can do is you can press escape and you'll be out of the command, and then you can go to your 3D, you switch to 3D, and there you have your truss. In yesterday's session, we said you can maintain this vertical one if you wish to have like a bonus type of situation. And we also browsed. We went to, I don't know if that was Google, if it was Bing, and we saw what a bonus structure looks like. If this is not what you intend to have, you can select it, properties. Here on heels here, it's showing that it's, when you zoom in, this is HR, this is HL, and this is HR, this is HL. So it shows you can have that go to 0 and that other one go to 0, and then you see, now you can have your gable, meaning your roof will only go there. So now you can repeat what we've just done like that over and over and over and over again. But that will take you a lot of time. And personally, if I can do something